Okay everybody, here it is, assembling the DIY Kits 70-watt amplifier. No one else did it, so I give up and did it myself. Hi there, this is KC1 JTS, also known as CycleCamp. And I am going to do something today that I see is sorely needed on the net, and that is I am going to go through how you construct one of these DIY, 50, 70, 100 watt, whatever this thing is, DIY kits, 70 watt, single sideband, linear HF power amplifier. There is no manual for this anywhere. There are no assemblies instructions for this anywhere. There's a lot of handwritten stuff about things to watch out for, a couple spots to watch out for, but there's no actual filmage of actually putting one of these together. It's boring, it takes a long time, but I really believe that this is something that was really necessary. So since I was going to put one of these together anyway, I figured I would document what I was doing. So for those of you that need it or would like it, here is my video, long as it is, on how to make this happen. So the first thing we're going to do is we're going to go over the parts, and I'm going to talk a little bit about how this thing is all put together. So basically, you get a PC board, and the PC board has a couple of things that you punch out of it. This group of two, this group of two, this group of two, and this group of two. And these things become the forms that, paired together with these inductors, allow you to create the specialized inductors that go here, and the two that go over here in that big column there. And I've already popped them out, so I'm just going to lift this up and take them out, pop them out. So basically, you've got these two pieces that work together to make that inductor. You've got these two pieces. Oops, sorry, I took it out of frame. You've got these pieces here that work together with these two inductors to make a frame, and that's also what these little pieces do. So these two pieces actually go inside these. And when you put one of these on either side of them, they create an assembly that you're going to run the wire through to make the inductors that go on this side of the board. Then this inductor, these two little pieces, go in here along with these pieces, and they make the inductor assemblies as well. Now, because of the way the board is laid out, everything you have to mount to this board. First of all, there's two different kinds of boards. This is the easier board because this one comes with the SMD components all attached already. Now, everything else on this board is also surface mount. There's no plated through holes in this, but at least all the really tiny stuff is already done for you. So that is one of the advantages, and I believe that's the bias adjustment pot right there. Sorry, I have one of my radios, so let me turn the radio off. There's the bias adjustment pot right there. But if you look at how this is done, you're going to attach a couple of transistors here. You've got a couple connectors here, offset there. Everything on here is pretty easy to get at if you put the inductors on first, except the relay. So the relay, I'm going to put the relay on first. But let's continue with the parts list. So you need the two inductors, right? You need the two inductors. I'm sorry, you need the PC board. You have the parts inside the PC board to make the forms for the inductor. I'll put those out of the way. You need the two inductors. You need the two tubular elements. You need the small inductor set and the tubular elements that make that. And this small piece of thicker wire, which is about 4.5 inches long, that's what you're going to use to make this inductor. Okay. Then there's another small inductor that's going to go over here. Okay, and that's going to use this longer piece of thinner wire, and also this main inductor is going to also use this wire. There's about 2 feet of this wire in the kit. Okay, then the other things that are in the kit, there are 2 inductors. There are 4 pieces of insulating material that's kind of like a rubbery material with holes in it. That's for these 2 transistors. These 2 transistors, these are the fake ones. You notice that they've had the information ground off of them, and those are actually supposed to be IRF 530s. A lot of people recommend do not build the kit with these. Buy yourself a set of IRF 530s and put them in directly. So that's, you can do that if you want, or you can not do that if you want. I don't care. Then you've got these little spacers here. These are insulators for basically when you install these transistors. You mount this thing to a heatsink, and you bolt the transistors to the heatsink. Well, these are obviously the insulators to keep the bolts that you use, the little screws that you use from touching. So insulate. So between these guys, and I think you only need 2 of them. Why they included 4, I'm not sure. And these 4, that's what you're going to get. So that's going to insulate those transistors. Okay. You've got 2 SMA connectors that are going to go here and here for your input and output for your RF. You've got 2 small 2-pin connectors. One of them is going to go over here. Oh, I'm out of frame again, sorry. One of them is going to go over here for power. The other one's going to go over here for your transmit peak push to talk button, because this is just like any other linear. You have to tell it when it's supposed to transmit with a push to talk. You got to close a relay or something, use a transistor that makes a connection on this. So that's what these 2 guys are for. And one of these jumpers is there so you can jump this in and out. I think it's kind of crude to do that, but what can I tell you? I didn't design the thing, I just bought it. Another thing you get is this cute little guy here. This is just a jumper assembly, and that jumper assembly is going to go right here, and basically you mount it so that the upper set of pins are soldered on and the other set of pins are open. And what this allows you to do is, if you put the jumper on the top, it jumpers out the low pass filter. You see there's a low pass filter connectors here, and if you elect to put in low pass filters, which is a very good idea, you can take that jumper off, and these other clips give you some place to keep it so it's still hanging around. So you mount it like this, such that the top is connected and the bottom is not connected, and then if you're not using a low pass filter, you clip it on the top. If you are using a low pass filter, you clip it on the bottom. Okay. The rest of the parts of the kit is the relay. Now the relay does not come like this. I have already bent the fingers out because this is going to be surface mounted. So when this comes with the fingers straight out like any other normal through-hole component would be. But I've already bent it because I decided to start this project before I decided I was going to make a video of it. And then the last 2 components that we haven't talked about yet are these 2 surface mounty kind of caps, and these are electrolytic capacitors. I believe they're 100 picofarads, or I'm sorry, nanofarads. I'm not sure, but I know where they go, so I guess I really don't care, because they're going to go here, and one goes here, and another one goes over here. So there's two different guys there. And I basically use you'll see there how they're electrolytic. They're colored on one side, so you know which one is plus and minus. And I just use the pictures to try to figure out which way to put them in. Okay, so that's all the parts that you need to start this project. All right, and what I'm going to do is I'm going to do individual construction a little bit at a time. It's going to jump around. The volume's going to skip around because I'm only going to do this as I have time in my spare time. And my biggest, like I said earlier, my biggest concern was everybody talks about these things. Everybody has videos where they test them, but no one has a video that I've been able to find of actually putting the goddamn thing together and trying to help you understand what order you ought to do things. Now, because there's no assembly manuals anywhere that I've been able to find, I'm going to do the best I can just looking at the project to try to figure it out. Okay, so I've already changed my mind about the order of some of this stuff, and here's what I've come up with. So I realized that this connector is right up against this relay, so I need to put that on first, and this cap is going to be perilously close to the inductor assembly, so I may have a hard time getting that on, and this guy. So I'm going to try to put the stuff around the outside on first, and that's where I'm going to start. So my decision has been I'm going to start with the SMA connectors. So that's what I'm going to start first. Now these SMA connectors, there's a pin in the center, and then you can see how it slides on. Well, if you want all three on the top, you've got to orient it with the 2 pins by themselves on the bottom, and then you'll have the 3 on the top, so that you get the connector that you need. So we're going to start with that, and please excuse me if this comes out of frame. I'm not used to doing this kind of stuff live on a video. I probably should have tinned the pads first, but you know what? Who cares? If you do one of them, you can use that to kind of hook everybody up. So I'm going to tin the pad first, and then I'm going to place the first place the first guy on there. I'll spare you the boring details here and skip ahead until I make my next major mistake, which will be bridging the 2 connectors. When I do the second one, I do a lot better job. And so now, of course, I bridged it, so I'll have to get rid of that solder bridge, but we'll take care of that in just a minute. I'll put this second guy on here. And let me get my solder sucker out. I am a solder sucker person. I'm not a wick person. Much as I enjoyed the wick movies, I am not a wick person. So, and we'll just skip right through the whole rest of that mess. Okay, so off camera, there was my smoke alarm going off. Because I was making a pot of tea earlier and forgot and left it on the stove, and all the water boiled out and got a little bit of smoke. So my smoke detectors are working. Don't forget to change batteries in your smoke detector. I do it every October. I do it on Halloween. I change all the batteries in all my smoke, carbon monoxide sensors, anything that's battery operated like my thermostat. Do them all on the same day every year. That way I know when I did it. So anyway, in the meantime, because that was going off and I couldn't record, I put on the other Sma connector. So the next thing we're going to put on is we're going to put on the little connector for the bypass of the low pass filter, which is going to go right over here. Okay, the next component we're going to put in is this little header for the low pass filter, and I'm going to use a miniature pair of Needlenose pliers to hold it because these are going to get pretty hot. The board is already tinned on these 2 pads, so I shouldn't have too much trouble positioning this. So we'll just tack the first one on, and then, excuse me while I turn this around, and we will tack the second one on. And then, because there's not, well, there was enough to tack it on, there's not really a lot of extra solder there. We're just going to run a little bit more onto the pad. Make sure we get a nice mechanical connection, because that is basically all that's holding this on is that one little solder connection for the on that little pin. There's nothing else holding on to it, so we're just going to slap that right in there, get it nice and juicy, and hopefully that'll be plenty. Okay, and while we're at it, just so we don't lose things, I'm going to take the jumper. I'm going to take the jumper and put it on as if I was jumpering out the low. I'll turn that around so that it's oriented properly. The low pass filter in, low pass filter out. So basically, this connector just jumpers into out, so it disconnects the low pass filter. And if you want to use the low pass filters, you move the jumper to this lower pair, and that just gives you a nice keeper for that. Now, the way I was always taught to do it was to do it like this, but maybe they don't want that hanging off. I don't know. But in any event, that's the way we're going to do it. Okay, so the next thing we're going to put on, I think, are going to be our other little connectors for the push-to-talk. These 2 white ones, the push-to-talk and the fan. Now the fan goes right here, so I guess we'll do that one next since it's right on the end of the board and it's easy to reach. So this time I'm going to put a little tin on that. There's not a lot of tin there. There is a little, but not a lot. So I'm going to put a little bit of tin on that. so that we can get this oriented properly. There we go. And then we'll get the other side on. Do I have that? Nope, it's in frame still. Okay. Just making sure. I know this is really boring to watch this, but people complain they don't have a step-by-step instructions for this. And then we're going to put this one on a little stronger. Again, because the only mechanical hold you have is what that little piece of solder holding that. Now that's why I don't like kits that use these surface mount ideas. I really prefer a plated through hole where at least the hole gets a good grab on that, but hey, can't win them all. So this is the fan connector, so that's all done. So now we're going to go find the connector for the push to talk. That connector's right here. I'm sorry, I'm out of frame. That connector's right here, so we're going to turn this around, stick it, these little jigs. I just started using one of these, and they are so much easier to deal with. So again, we're going to take one side of this and run a little tin on it, a little solder on it, and then turn it around so I can reach it. Am I in frame? I've got, I'm having a little trouble keeping all this stuff in frame only because I have my camera so close, because this is really small and I want you guys to be able to see what I'm doing. So there's the one side of it. Here is, now we're going to solder up the other side. Again, the only thing holding this component on there when you're shoving that connector on and off, or when you're putting the jumper wire in there for when you're going to run your push to talk from your radio, the only thing holding it are those two little bitty legs on that solder pad. So and just like we did before, just so we don't lose it, because I have a tendency to lose stuff pretty easy, I'm going to take this little jumper and stick it on there. I think these might be a little bit bigger than the standard little tiny jumper, but it will go on there if you give it a good shove. Okay, so we have put everything on but the caps, so we'll do the caps next. Now I'm going to have to stop a minute and go look at the picture. So here's a picture of a completed one, okay, and you can see the cap in that corner. I've got this oriented backwards, so let me turn this around so it's oriented properly, and then we can decide what we're doing here. So the cap in this corner is oriented with the black to the top, which is away from the, I don't know if you can see it, but there's, on the outline, there's a little triangular part on the outline, but on this one, the capacitor has the black on the opposite side. So that means that this capacitor here is going to have the black on the inside, and sure enough, that does match up with that does match up with this picture. So that is how I'm going to put the caps on. Now these caps, they come in this really cool little blister thingy. I assume that these are, for automated installers, robots or whatever. But not sure how you get these off without breaking them. So let me get a scissors out of the drawer, and we'll see if we can. It's close enough to. Yeah, there we go. We can open that up a little easier. All right, so dump them out. I mean, obviously these are not electrostatic, parts that worry about that kind of stuff. They're just a pain in the butt, and you don't want them flying across the room like that one almost did. And also, like I said, because these don't have there's not a lot of connector here. Okay, so, all right, so they're out of the plastic. Man, what a wrestling job that was. So here we are with the guy, and these are going to go like this. And there is a what do you call it? There is some solder on there, but because you can't really get underneath this very well, I'm going to add a little bit before we start, because when it comes to that kind of stuff, I'd rather have too much than too little. So I'm just going to double check the picture again. So this one that's going, here's where the inductor goes, and this one has the black facing the on the edge of the inductor. So we're going to stick it in like this. So there's one side. Would have helped if I'd have kept my glasses on. Oops, yeah, I messed it up. I didn't have it close enough when I put the first one on, and so as a result, when I moved it to line it up, I tore it free, so I'll have to do it again. Okay. So there we go. And that's on there. Alright, so that's one. Now we'll go do the other one. Now the other one's up here, so I'm going to reposition the board in the jaws of life here. And we decided that the black on this is going again towards the flat edge. So that one's going in, oops, in this orientation, like that. See, it's opposite the other one. And I'll do the same thing I did before. We're going to tin that up just a little bit more. Just a little bit more grab. Come on. Okay. Helps if you leave it on there long enough to actually do something. And then we're going to take that and stick it in there. Alright, so there's the back. Turn it around and get the front. There's just a very tiny thing out here, so that the lead is just small enough that you can heat the lead up good and then get the whole thing to set down. And that's basically what I'm doing. I added a little bit of extra solder, and then I'm just heating that lead up enough that I can get the whole thing to set down properly. Okay, so that's it for the small components. So I think the next thing we're going to do is start building inductor packages. So let's take a look at that. That's going to be a lot of fun. So what I'm going to start with, I'm going to start with the big ones, because I figure big ones are easier to work with than small ones. And basically I'm going to use these components and I'm going to build this. So what I'm going to do, you see these are symmetrical. They're all exactly the same. They're two omega shaped lands on both sides, but you want to make sure they're oriented in the same direction, because you've got to solder the flat sides later. And then I'm going to stick the two ferrites, not inductors. They're not inductors until you finish building them. And then I'm going to take the two tubes and put them down through the centers. And then I'm going to add the little block to the top. Now, the important thing here is to make sure, and I'll do it by doing it this way, is to make sure you've got these things on both sides, so very little of this sticks up when you're done. And make sure that that both blocks are oriented the same way. Now when you do that, what I'm going to do is I'm going to solder the tubes in first. But you want to solder the tubes to the outside, but you do not want to fill in the hole at all. And I'm just going to see if this works, because I don't know if this is actually going to work or not. But my understanding is you have to make a connection between the tubes and this outside land on both sides to make the half-turn return path. Now this is a very big assembly, and I'm not sure if this iron is going to generate enough heat for me to do that. It looks like I got it tacked on that side. So let's tack it on this side. I do not know. Obviously, there's no instruction manual, so I don't know if you have to really make this all the way around or not, or if it's even possible to do that. But I figure if you put enough solder on it, you'll get it one way or the other. I just figured making the form first would be easier than trying to build it on the board and trying to keep all this stuff together and spaced properly and all that kind of stuff. Okay, so that looks, oh, that one came pretty good. So we're just gonna, I'm just gonna keep farting around with this until I get it until I get enough of this stuff. Now I can use gravity to help me, you know, once I get these secured pretty well. I can use gravity to help me run that solder in. Yeah, that's much better. Okay. Now, of course, I've lost the ones on the other end, but that's life. So that's the object of the game. Is you're going to do them, you know, while, and then now I can turn this over and do the other side. Double check. Yep, there's the long edge there. I can tell because the snap off point is pointed up, and there's no snap off point down here, so I can tell, you know, where it snapped off of the PC board. So now we're going to do this side. And try to put this together. Again, you want to solder these, you want to solder that internal pipe to these, but you don't want to fill up the inside because you've got to run wires through there. The other thing, you probably don't want a lot of solder like sticking out there because you don't want it to make a sharp edge and chafe that wire. So, alright, so that's one side. Now let's go do the other side. I'm sure a welder would know how to do this smarter, because they probably have to do stuff like this all the time. But I'm just an old fart, and I don't really do this that well. Okay, so now I have my assembly, and you can see the flat edges are correct on both sides. This is pretty hot, by the way. It's pretty warm. I'm going to do the top a little better. Okay, so I've got my first assembly, and that's going to basically come here, and this is going to go on here, and then I'm going to solder the, then I'm going to solder these little pads to these lands that are on the board. So they're going to go in like that. And I think doing it this way and then soldering these on is going to be a hell of a lot easier than trying to hold that thing up, solder it, hold this up, solder it, stick this stuff through, always at the right length. I think it's a real pain in the ass otherwise. Alright, so we did one, so now we're going to do the other one. So now we have this piece of ferrite, the small piece of ferrite. Again, we've got the two parts. Again, they are symmetrical. You know, they look exactly the same on both sides. So we're going to stick this through here, and we're going to make sure it goes through the bottom. Yeah, I saw it drop down. We're going to take this one, drop it in, make sure that one drops through the bottom. We're going to try to make sure it drops through here. Come on. Excuse me a second. Okay, so that one's through, and then we're going to put the cover on the top. And this is going to be a little tougher because this is a lot smaller, but we'll do. It's basically the same idea. So basically we're just going around here with the solder, and we're soldering the inside of that little tube to this form, standoff, whatever you want to call it. Okay, so that's one side, or one edge. I'm just squaring it up, trying to square it up a little bit. Yeah, that didn't work. Nice try. I figure if I get these right, then I'll worry about getting it good and square when I tack up the other side. Well, then that would come out really pretty. Isn't that funny? Okay, so here we go here. Alright, so there's those two. I'm going to turn it over. Of course that's going to fall off, but that's okay. And now we'll do the back side. Whoever cut the tubes, the little tubes, did a much more accurate job than the guys that cut the big tubes. Because these both match almost exactly, and it actually makes it a little easier to work with. I think first we're going to deposit a layer around the outside. Alright, so this has to be... Now, I've got this little cockeyed, I don't know if you can see it, but the two of them don't line up, so I'm going to lay it on the ground and then run it around once, see if I can get it. Yeah, see, now I can get it to lay flat, or a little more. And whatever, you know, I mean, I'm certain I can bridge it if I really need to. And of course the difficulty is that little tube conducts a lot of heat. So, just for fun, I'm going to set it on the board, see if it's a real problem. Yeah, it is a problem. It needs to be squarer than it is. So I'm going to, let me see, I think I'll use my, Use my little pliers here to, yeah, that's much better. It's not perfect, but it is much better. So, okay, and that should be within the realm of connectableness here. So now we'll do the other side. Okay, so there's the other guy. And now the question is going to be, do we run the wires first? Oh, I'm sorry, I got one more thing to do. Damn it. Okay, I got to put the relay in. So, sorry about that. So let's put the relay in next before we try to drop that monster on there. Again, the relay pads are already, there is a little bit of tinning on there. So, as I have in the past, I'm just going to add a little bit more. It just seems to work a little better that way. I'm not sure you need to do it, but again, when it comes to this stuff, since it also makes the mechanical connection, I'd rather have a little too much than a little too little. Excuse me. So here's the, you can't do this wrong. There's three sets that are close together, and then there's one set that's further apart, and there's three sets here that are close together and one set that's further apart. So it's really hard to do this wrong. Not impossible, I'm sure, but just difficult. Now I'm going to put all the one side on first, because obviously you can't make it drop evenly across both sides if the other fingers aren't soldered down yet. So I'm going to do it this way. There we go. That's looking good. Okay. And then, as we have before, we'll take just a little bit more, solder and run it in there. I am old and my eyes are not good, and I really dislike working with SMD components, and I really dislike working with surface mounts. I have nothing against Manhattan as a city, but when it comes to the Manhattan method of attaching components, not so much. Anyway, so I'm sorry, that was out of focus, but basically all I was doing was, building this up a little bit. Okay, so we've basically got everything assembled except these two transformer assemblies, and there's another transformer assembly that goes right here, but it doesn't require, oh, and by the way, mine was chipped. You'll notice that one side is really nice and clean and the other side has a little chip in it. But hey, that's life. I don't think it's going to make a huge difference, but I just thought I'd mention it. So the only components that are left are the transistors, their insulating components, and these two inductors, and this last inductor over here, and that's it. We're almost done. So we're in pretty good shape. So I hope this is working out as well for you guys as it is for me. I'm going to take a quick break and go back and look at the diagrams and stuff and make sure I know how to wind these. Make sure I know how to wind the transformers. So hold on just a minute. Here are the inductors. Okay, so the first thing we're going to put together is the what's called the power choke, and the power choke is the one freestanding two-element ferrite. The one freestanding two-element ferrite. Sorry, I've got this camera so screwed up here, twisted on the stand. Okay, this one ferrite, and we're going to use this piece of wire. Now, I've read comments that this wire has a weak coating, and it might be better to use another kind of wire for that. Some people say avoid it to avoid shortcuts. I think they make short circuits. But the bottom line is you need to go through this twice, and then when you get done, you're going to bend these fingers out like this, and that's how you're going to solder it on. So I'm going to take this one here, and of course it's not a very easy. It's a fairly thick. It's a fairly thick piece of wire, so it's kind of hard to get in there. But that's just the way it goes. One of the joys of doing kits like this is you get to mess around with all kinds of fun stuff like this. So, and basically what I'm trying to do is I'm trying to leave just enough wire on the ends to be able to tie it down. But we shall see. Again, this is very thick stuff. Now remember, when you're winding a toroid of any kind, that the number of times the wire passes through the center counts as a turn. So that's pretty important stuff. So here we are. So we've got 2 turns on this side, 1 turn on this. 2 turns on this side, 1 turn on that side, because we came in around once, and now we're going to go back down in, and this is going to finish our wrapping of this particular choke on this toroid. Now I do not, I didn't really want to do that. I want to come through the center of that one, because I want to make this a little tighter. So I'm probably going to have to play with this a little bit to get it to be a little tighter. Alright, so that's that one. Through there. Not easy. I'm going to back it out and do it again. Alright, so we have this. There, that's a little tighter. This heavier wire material is not easy to work with. Now we're going to go through here again, debating whether I want to go over the top or over the bottom. But it's all part of the fun. I'm going to try to go over the bottom. I'm trying to get them to sit next to each other and not cross each other, basically, is what I'm doing. The internal loops. It really helps you if you have one of these little small pliers, miniature pliers. Okay. So it's not too bad, but it's not too good. So basically I want to get these smaller. Okay. Alright, that doesn't look too bad. Yeah, now I've got it so it's not too, you can see it doesn't, I'm sorry, I'm out of frame. It doesn't move too much. I've got it about as tight as I'm going to get it. I'm going to bend these up. And I'm going to, the way I normally do this is I use either a wire stripper or an X-Acto knife, depending on what kind of wire it is. Since this is just a lacquer covered wire, I'm going to use an X-Acto knife. I'm going to leave the wires long, and I'll cut them to size afterwards. So I'll get an X-Acto knife set out here, and we'll get I prefer a squarish blade when I do this, for those of you that care what kind of blades people use. So I like a squarish kind of blade. I find it easier to control, one that has, more of a point with a relaxed guy like that. Some people use the one that looks like a scraper. Now, since we know this is the part that's going to be, here we go. We know this is the part that's actually going to get the solder applied to it. We'll do the bottom first. And basically all I'm doing is removing the lacquer so that we can get it to tin up good. And I'm going in pretty close to the ferrite itself, because when you look at the outline, you can see that the legs are only going to extend out of the ferrite about 1/8 of an inch. So I figure if I start at the ferrite, then I'll probably be in pretty good shape. And if I mess it up, then that'll give me an opportunity to go get some more wire, I guess. Alright, so same thing again. I'm going to make it, do it on the bottom because we know that's where it's going to get the solder applied, most of it. And of course, doing this with the inductors, you know, with the ferrites and the wires, this is the longest part of this whole project. Everything else goes together very easily, but this is a major pain in the stones. But it could be worse. Could do this for a living instead of a hobby. Ugh. Okay, so now I'm going to get my trusty miniature diagonal cutters, and we're going to cut that about 1/8 of an inch away, and hope that's enough. We'll cut the other one a little bit longer. I'm sorry, I'm out of frame again, so we'll cut the other one a little bit longer. I think that's probably a better place to cut it. And then we'll take it here and see. Is that going to be good? Yeah, they're both pretty good. Either one of them is okay. But I'm going to turn this around in the tool because I can't reach it with the soldering iron. So we'll turn it around in the tool. And get it all. Okay. Now what I'm going to do, before I try to put this on, I'm going to try to tin the wire itself. Because that'll tell me if I've got it stripped properly. If I can't get it to tin, then I know I don't have the... Yeah, that looks pretty good. Put my glasses on again. Yep, there you go. That looks like it's tinning pretty well. Try both sides. Oh yeah. Cut on both sides. Not too much glop. Okay. Then we will take the two pads again. The two pads do have tinning on them, but I like to have a little more when I start this. Also, it's fresh solder with, you know, this solder has nice rosin in it, so it's rosin core solder, and you know, so it tends to stick a little better. Okay, so now we're gonna put this guy on here. That's stuck pretty good. Around the outside. Ooh, see, now we learned something there. That one much better. Okay, we're going to put a little more. Going to put a little more solder on this side. Again, because this provides all the mechanical adherence. Ouch. Should have known better, right? I'm heating up a piece of wire. Duh. Or dope, if you prefer the Simpsons. Yeah, that's better. And this side, I think, is good. I don't really need to trim this up too much. No, that side's good. I'm going to leave it alone. Okay, so now we've got that piece on. You'll notice from what we had left over here, they don't give you a hell of a lot of extra wire. There's only got you know, those two, well, I can't see them because they're stuck in my fingers. There. You can see there's only those two little pieces of wire left. Not good. Okay, so that takes care of that. So that's and if you're looking at the schematic, I believe that is inductor, well, depending on which schematic you're looking at. Let me get the other schematic, hold on. There you go. 3 to 30 megahertz Class AB amplifier. I believe that is 2 turns. 2 turns. That's not it. That's not it. That's not it. You got me. Well, that's a good question. I'm not sure which one that is. But I know it's 2 turns. And it does not have, it's not a transformer. So I should be able to find, I've got a part here that's just marked inductor. And that inductor does not have a listing of how many turns to put on it. But if you read the documentation someone else has written, that's the power choke, which has 2 turns. So apparently that is a power choke. So where's power coming on this thing? 13.8 volts. Yeah, that would be this inductor right here, I believe. So I'm not positive. And then the other 2 guys we're looking at are this one, which is actually a transformer, and this one, which is also a transformer. And one of them has 2 turns by 1/2 turn, and the other one has 3 turns by 1/2 turn. And the 1/2 turn is created by the tubular elements. When we solder this down, those tubular elements are going to be connected on one side and individual on the other, and they provide the 1/2 turn part. And the same thing happens with this. The tubular elements, when you solder this down to this pad, you're going to have 2 opens and one where they're closed together like this. And that's what gives you your 1/2 turn. And also, you can, I don't know if you can see it, but you can see that if you don't get this square, you are going to have some trouble soldering this in, because see, it's cockeyed on the part. So I should have done a better job at that. But you guys can, if you guys can figure out a better way to do it, more power to you. I'm sure there, and I'm sure maybe if you put this in a clamp and then solder it while it's in the clamp, it would stay better. But this is my first attempt at this, so you're stuck with my mistakes. Okay, so the question is, which one is which? Which is the 2 turn and which is a 3 turn? And by the way, I made a mistake in the very beginning of the video. I said the thick wire was for this as well, and it's not. These 2 guys both get wound. These 2 guys both get wound with this wire. So don't let me screw you up. Okay, so I'm going to poke around here and try to figure out which one is which by looking at the picture. Again, there's a lot of different pictures of these on the internet, and it's sometimes it's very difficult to tell what's what. But I am pretty sure that I see 1, 2, 3 turns here. There's this little piece of wire that goes underneath, and these 2. So I think this is the 3, and I think this one is the 2. 1, 2. And so you're going to put 2 through here, and then the 2 ends are going to connect out here. You're going to put 3 through here, and the 2 ends are going to connect out here. So what I'm going to do is I'm going to try wrapping one of these, and then I'll open it up and tell you how much. I'll take it apart again and tell you how much cable that I used, how much wire that I used. So there's one. I'm going to fold that up, and then we put it through again. And this is how I would do it. I would do it on the outside like this. So there's 2. This is a lot easier to do because this wire is more malleable because it's a lot thinner. So that's 2. And I apologize for this going out of frame. I should do this down below. And then here is 3. So here comes, whoops, screwed that up. 1, 2. Probably would have helped if I'd have got it through the other side. Here we go, 3. We'll stick that through there. And bring it back around here. And there is 3. And that's way too much wire left over, so I got way too much wire left over. Those pads are going, those wires are going right here to these 2 pads on this side. So this is going to mount like this, and then we're going to put those 2 pads in. And the reason I want to figure this out first is because I'm going to solder this in before I run these wires, because if I run the wires first and then I try to solder it, there's a good chance I'm going to burn the wire with the iron while I'm farting around in there. So what I want to do is I want to mount this and then run the wires. So that's basically what we're looking at here. So just for fun, what I'm going to do is mark this with a, I'm going to mark this with a Sharpie. And the other thing is, when we get done, you don't need all of that. You probably only need what looks to be about a 1/2 inch of, you'll need about a 1/2 inch of wire on there. I don't have a measuring implement that's that small. This one is a little big for that, but yeah, say 3/4 of an inch. Give yourself 3/4 of an inch to you know, in case you break it or screw it up or whatever. But yeah, so so this guy here, I would say when we get done measuring this, so that's an inch, that's 3/4 of an inch. I've got about 1.5 inches. So we're going to take 3/4 and 3/4. We're going to take about 1.5 inches off this measurement when we take this apart. So let's take it apart and see how much wire we really need. And you know, you might, you know, don't go be weird about it. You know, if you think you need a little more, take a little more. Just remember, you gotta run both of these. So on this side, you won't be able to see this because I'm focused down too far. Of course, I dropped the wire on the ground. But on this side, I believe, if I haven't lost the orientation of the wire, I believe that we are looking at how much? So we're looking at about 13 3/4 inches less. 1, 2, 3/4, 1, 2, 3/4. So we're looking at about 1 foot. But I would give it 1.5 inches. I wouldn't cut myself too short. So that's what I'm going to use for that side. Now, just for fun, before I cut this, I'm going to test wire the other side, which is 2 turns, coming from the other direction, and see if that works. So where's my? Of course, oh, there it is. Okay. So that's 1, and then go through it again. And that's 2. Yep, and you'll have plenty left over to wire the 2-banger. Okay, just make sure when you wire this, try to make both ends come up on the same, you know, come out. Don't cross the wire like this one is. You know, make them come out the same side. So you should be okay. And you know that whole measure twice, cut once thing. I'm gonna do the big one again. Now that I know I've got a ton of wire left over for the little transformer, I'm gonna wire the big one again, just to make sure that I did it right. So we're going to take about 3/4 of an inch and run it through once. And run it through twice. Don't kink it up, kinks are bad. So run it through twice. And run it through a third time. And with about that much left. And again, we're looking at, so 1, 2, 3. I've left myself plenty of room to get to those pads, right? Plenty of room to get to the pads. And we'll cut it right there. This time I'm going to cut it. And now we'll have a, and this is not wrapped real tight, so you'll still have a little bit left over. So let's back this off and let's see how much we actually used. So we're going to back this off. And the amount we used was just about a foot. So we're just about there at a foot. In fact, we're just at a foot. So I would say if you cut a foot of wire to wire the larger of the two, cut a foot of wire to run the larger of the two, you should be okay. So I'm just going to add that to my notes. Disassemble double, put the other PC boards on our tube to the trace on top of the P board. Okay. 3 turns, don't do that. So next thing we're going to do is G. We're going to cut 12 inches of wire. And then solder to. Okay, so let us stop this. Okay, so now that we've decided how much wire we need to use, let's talk about positioning the first transformer, the larger of the two. So there's a couple things here. First of all, these two ends, right, you see how the silver pads line up with the silver pads on the board, which is great, but do not put them out so that when you solder them up, you cover these little tiny holes, because these little tiny holes are for these last set of inductors. There's a set of inductors that's going in there, and I don't think that they want to be shorted out to that. So you have to orient this two ways. You have to make sure they're lined up even on the pads, and you have to make sure that end to end that there's enough, that you've got them overlapping enough that you can solder them in. So those are the two things to worry about when you go to put these on. Okay, so I've got mine pretty close to where I want it to be. I'm going to do what I normally do, and I'm going to take, oh, that's a piece of wire, I don't want that. We're going to take a little bit of solder, and we're going to build up on this pad something we can tack to, but not a lot, because we want this thing to set, sort of flat before we start really putting it in. So we're going to do that. And then we are going to bring this over. Try not to have it fall out of the hole. We'll check our alignment on this other side here. And then I'm going to very gently put that on there. And yes, I did catch it. So I have it overlapping on both sides. Could be a little bit better, but not bad. And now I'm going to run some solder all along this edge, and in fact I'm going to bring my jig up a little bit so that I can let gravity be my friend on this. And again, I expect if you were a welder, you would be looking at this saying, oh my God, if this guy really knew what he was doing, he'd be dangerous. because this pad is the same, this pad is the same all the way across, I don't have to be too careful about bridging anything, you know, because it's the pad on the pad here on the board is the same all the way across. And again, it would also help if I put my glasses on. So basically all I'm doing is connecting the end cap of this transformer to that side of the lands. Basically what we're doing. Okay, that was easy enough. Now we're going to turn it, orient it the other way. Now we're going to do the same thing, only oriented this way. Of course it'll be a lot lower. These are going away instead of going up. Again, now we have to be careful. We can't bridge these two solder pads. So you got to be a little more careful. Let us do this. You can see if you had run the wires already, this would be a major pain to do this without burning those wires. They felt like they were coated in Teflon, so maybe they could have stood this anyway, and it wouldn't have been a problem. But you know, better safe than sorry. And even though I might not have this perfectly square, you know, the two ends might not have been perfectly square, you know, you can build up enough of a solder deck here to get them all filled in really nicely. So here we go. Look at that. Ugh. Yep, there we go. Now that we have them in, we can wind them. Okay, so now we're done. Okay, see, that's all. I don't know, that one could use a little bit more. It's tough to see with the reflections here. It's sometimes it's tough to see when you have an open gap. Let's try again. That's better. Okay. Alright guys, so we have the first transformer positioned properly. Now what I'm going to do is I'm going to take the longer piece of wire, the 12-incher, and I'm going to take a look at my stripper and see if this stuff is easy to strip or not. Now this stripper is set to too low, so I need to tighten it up a little bit. Excuse me. Of course, if you have a nice automatic stripper, you know, this will work a lot better. So that looks pretty good. Let me try it again. Yeah, that came out nice. So now we have a nice stripped little end, and we're gonna bring this through this way until we know we can reach it. Get this where you can see it. So I'm for this I'm going to bring this up a little bit. Hold on a minute, bring the camera up a little bit. Okay. So I want to be able to do this with very little waste. So here's my. In fact, maybe I'll tack that down. I don't know if this is a good idea or not. So this is just an experiment on my part, so you can see what's going on. But the first thing I'm going to do is take and fatten this pad up like we have been doing. I'm going to do both of them actually. So fatten the pad up. Come on. Yeah, I am really glad I didn't do this with the wire connected. Make that a nice big chunky ball there. There's another nice big chunky ball. Beautiful. Okay, so we're going to take this first piece of wire, I'm going to put it in from the back side. right? And I've already bent it, and I'm going to tack it on. And bent it quite enough. Bend it a little more. Come on. Well, either I don't have it stripped as well as I thought, or there's something else going on here, because I cannot get the I can't get the wire to tin up to it. So let's take another look. I think what's going on is I can't get enough leverage on it from the back side of the transformer, so I'm going to need to find my little guys here and do it again. Alright, so in through the back. Wow, I didn't think this was going to be this hard. Huh. Not happy. That's okay. A bigger blob. I'm definitely having a hard time getting it hot enough, getting the wire hot enough to melt the solder. If I heat the wire and try to get the wire to settle into the solder, it don't want to do it, which I find quite interesting. Okay. Yeah, I just had to heat the hell out of the wire. That was pretty weird. Of course, did I grab the wrong piece? Yes, I grabbed the wrong piece. I got the short piece. Oh, maybe I didn't. The short piece or the long piece? Oh, they're both about the same. Okay. Guess I'm good. So let's walk it through. So that's 1 Mississippi. Again, I'm trying to actually coil it in a real coil. So that's 1 Mississippi, and now we're going to go through here again. Mississippi. basically what I'm doing is trying to keep it tight. And if I bring this down, I don't know if I'm going to be able to get the wire strippers close enough, but we should be pretty close. And I'm going to cut this because if I try to move that amount of insulation, it's not going to work. So nip that off, and we'll try this again. Yeah, okay. And then we'll bring this down again, and that ought to do it. Okay, so let's try to solder this side up. So we've got our three passes. Put the glasses back on again. I do have a very difficult time getting this wire to accept tinning. I wonder if it's Teflon coated and also has a what do you call it, a lacquer and enamel shield on it, because it just does not want to take the solder. And I can't tell if it's because it's too good of a heat sink or what. I'm just going to heat the snot out of it until, yeah, there we go. Can't really see it, but I'm trying to press it down, and yeah. Good. Okay, so that's the first big inductor. What a pain, huh? Oh my God. I'm glad I did it the way I did it, though. Okay, so now we're gonna turn this over, and we're gonna go for the second one. Okay, so now we're gonna try the second inductor, the second transformer, and we're gonna basically use the same strategy. So let me flip the vise around just so I can reach that better. And we're going to work with these pads here, and the wires are going to come off this way and attach to these two positions right there. So I'm going to do the same thing I did before. I'm going to take my strippers, and I'm going to strip the very end of this wire off. Okay, that came out okay. You can see that. And now the first thing I'm going to do, same as before, you need to position this so that it covers front to back and left to right. These two guys cover, but do not short circuit each other. So this one has a lot more. They left a lot more space on the board for this. It looks like there's a couple ways you can do this. So I'm going to bring it a little further out, and again, we're going to do the same thing. We're going to run a little pool of solder on there. I like using the fat pad first because it's just easier to deal with. So we're just going to have something there as a tack point. Then I'm going to bring it back, and I'm going to line it up here. I'm actually going to bring. You see how this is L-shaped? I'm going to bring it back on the tops of the L's going that way, because there's a lot less margin for error if you do it that way. So okay, and that's not quite right, but it's close, so let's try it again. And line that up a little better. Okay, now I'm going to try to permanently affix the butt end of this. Oh, same thing. So let's let gravity be our friend, and we're going to point this up a little bit, and we'll run the solder on the far side first. Got a little more reach here because I didn't do a very good job lining this up. I've got one of these, this end cap is cockeyed. In fact, this is the bad end, so this is good. I'll do the bad end first. Okay, so there's one of them. Now we'll go back and get the one that we just tacked on, and we'll make that a little more permanent. Look at that. Yeah, it's not too bad. Got a couple of open spots. You know, I don't know that you have to cover the entire area here, but you know, I'd rather have it. You know, the more mechanical adhesion we can get, can't hurt that much. So. Okay, yeah, so we've covered those where the, you know, where the tinning is on the form. So, and this side, this looks pretty good. These are going to line up pretty good. I mean, they're kind of in the air a little bit, but I don't think I'm going to have a real tough time getting that to stick. So let's do the same thing again. But of course, on this side, you got to be careful not to cross these two pads. These two pads are supposed to be separate. Very nice. That one came out okay. Now this is going to be another hard one because this one's kind of up in the air. What I'm doing is I'm putting the solder on the top and letting gravity, you know, when I get a big enough blob, I'm letting gravity drag it down. Pretty close, not perfect, but not bad. This side's pretty good. We knew this one was going to be a little bit of a problem, so we'll just do it again. Okay, that looks pretty good. So now we'll do the same thing, and I believe we said from the schematic, I'm pretty sure we said that this was the two-turn one. Let us do what we did before. We're going to blob some solder in here to give us something to nail to. Check the schematic again. So that's the wrong schematic. Try again. There we go. These, and I'm sorry, I'm switching back and forth. These were from two different websites. This one's in Chinese, and it probably has like the number of turns and stuff, but I can't read it, so you know, whatever. And this is from another gentleman that did a much better job. PA-11019.blogspot.com. So this was the 3 to 1/2 on this side, and this other side is 2 to 1/2. So this is the 2 to 1/2 side, and so we have our other piece of wire here, and it worked really well before. Me soldering it ahead of time, because it allowed me to, mechanically pull on it a lot harder. So I'm going to do that again, only this time I'm going to bend the wire a little bit differently to see if I can get it to come down a little further. Yeah, no, that didn't work. Nice try though. Okay. So we'll come down for you again. I don't think this is really going to be terribly exciting to watch, but you can see what we're doing here. So I'm going to tack this first one on. I'm just bending the wire again. Yeah, that's better. I'm going to do what I did the last time and heat the wire and the solder up until the wire finally gives up and accepts the tin. I'm going to use I can't really manipulate it very well. I can't really manipulate it very well from the other side of the inductor, so I'm going to get in here with my that's much better. Okay, so now we've got that one end tacked, so now we're going to wrap it around twice. So here's one Mississippi, and see, being able to pull on that's pretty nice. Now this time we're going to do something a little different because I don't think we're going to be able to, I don't think I'm going to be able to get the tool close enough to strip this other wire. So what I'm going to do is I'm going to bring it down and I'm going to mark it like we did before and say I think I need to strip it here, right about there, and then I'm gonna cut this off right about there. Now I don't think I can get that close enough to the coil, so what I'm going to do is just push this back out through and then strip it and stick it back in again, just to make that a little easier. I'm basically a lazy guy, and I'd rather undo a little bit of work and then hit it again. All right, so here we are. We have our mark, and we got a nice clean strip. Right, nice clean strip right there at the mark. So we're happy. Now we'll see if we can jam this in again. Of course, the difficult part is getting it to go back into the same hole. There we go. Just got to use the right tools. And okay. All right. So now we're going to bend this down and bend this up, so get it to lay nice and flat. Okay. And same as before. Can't really do much with it. Can't really do much with it from inside, so we're, oops, sorry, I whacked the thing. So we're going to take this and use it to hold this down if I can get a grip on it. I'm out of frame again. Of course, when you get the right grip on it, you're always out of frame. I did get it tinned up, but I don't have enough heat here to get it sunk down good. And of course, when I use the pliers, the Needlenose pliers, they act like a heat sink. They draw the heat away from the joint. What I'm going to try to do is just catch the end of it. Yeah, that's better. So if I was going to do this again, I would strip a longer piece. I would strip the wire a little bit longer, like it is on this side, like it is on this side, so that I could grab it a little easier. But I do have it on. So we have our second transformer on. So we're very happy about that. So what is? Oops! Jeez, my freaking Sharpie's going to go all over my shirt. So what's left? So all we have left for parts are the two transformers and the two inductors. Now the two inductors, as best as I can tell from the pictures, the two inductors go from this pad to this pad and from this pad to this pad. And boy, I tell you what, there ain't a hell of a lot of wiggle room there. So, but luckily these are leaded components, so it shouldn't be too bad. I hope you can see that better. I open this up and I hope you can see that better. So here's your this pad and this pad and this pad and this pad. So if I was going to do it, in the pictures, what they did was they ran them sort of over the end of the transistors. So the transistors are going to end up being right about here. And what they did was they ran them over where the transistor leads are going to be. But if you're going to do that, that's fine, but make them so you can rock them up. Because if you can't rock them up, then you can't, you're not going to be able to solder the transistors. And you'll notice I'm not putting the transistors in first. And there's a reason for that. The reason for that is I don't know what kind of heatsink I'm going to be using yet. And since I don't know what heatsink I'm using, I don't know how far in or out the transistors are going to have to be to catch any holes that might be in. You know, there might be pre-drilled holes in the heatsink. So my recommendation is don't put these final parts in at all until you get to where the heatsink is. You know, until you get your heatsink and you know what's going to happen. In the meantime, okay, that's too big. So what I'm doing now is I'm trying to find out how to bend these at a 90-degree angle to have them be the right length. Of course, a smart person would have measured them first, but I'm not that smart. So, but since no one else put this stupid kit together, all these people that show you, oh, here we're testing it, and they don't actually tell you how to, how to make it. Shame on those guys. All right, so this looks pretty good. Let me try it from the other side. Yeah, that doesn't look too bad. It's pretty close. Let me just straighten this one out a little bit. So if you're smart, measure the width of these pads first, and then do it. Okay, if you're really smart. And what I would do is I would just set them up so that they go up over the transistor itself. Now those transistors get pretty warm. Maybe that's how come they don't want to do it that way. I don't know, but I'm sure that if you do it like this, right? If you lay the geez, here we go again. Me and my stupid camera. I'm sure that if you did it like this, right? That's going to show you about where to cut them, and then you'll still have plenty of room to bend this up. Right when you want to put the transistor in. So I would lay it on the edge of the board like this, get a feel for where it's going to be, and snip them off. I'm so close. I apologize. I'm so close to the part now that I don't have working room for my hands. So give me a second here. All right. So oh, I suppose I could use my handy dandy marking pen again. Hold on. So lay it on. What I would do is first bend them. First get them to be about the right distance apart when they're bent 90 degrees, right? And then lay it towards the edge of the board, and then mark the far end of the pad on the lead. And I'll show you why we're marking the far end in just a minute. Then you're gonna nip them off at the far end. And then I'm going to bend them the other way. And the reason I'm bending them the other, in line with the part. And the reason I'm bending them like that is because I don't want to touch these pads. I don't want to have any chance at all of touching those pads. So I'm going to bend them. You can just barely see the little bend in them, right? The little feet. And that's where I'm going to solder them. I'm going to solder them on right there. And hope that that's good enough. So, what do we do when we're going to solder? Well, first we're going to build up the pad. And in this case, we might also tin the part. I don't know. But again, be very careful here. Don't get the solder on the... Don't solder bridge here. You'll be very sorry. Okay, so here we go. Now I'm going to take the... So I solder bridge both of those. Now I'm going to take the component and I'm going to just tin the leads a little bit. Maybe. Okay. And now I can take this part. Oh, wait a minute. I didn't bend it 90 degrees. Oh, I think I did. That's actually solder hanging down. Hold on. Yeah, that's solder hanging down. Too much. Too much is solder. Now you want to be very careful. Don't bend this too much because the only thing you got holding this together is that pad. And you snap that pad off, you're going to have some problems. Okay? But that's how, now I got this one a little too far off the edge, but you can see I've got plenty of room. If I want to bring this up, I can come under here and I can still solder this transistor in if I need to. Sorry. If I bring this up, bring this inductor up, I can still solder that transistor if I need to. Now I apologize for keep knocking the thing out of whack. So let's turn it over and do it again. Let's do the same thing again. So we're going to take the part. First we're going to bend it in approximately the right spot, and since they look like they're both the same, so since I've already done one, I can get a lot closer hopefully on the first try with this other one. You only need about 1/8 of an inch on, or less, 1/10 of an inch maybe, on either side. So we'll get it so it's pretty much 90 degrees. We'll check it. Oh yeah, that looks good. I'm going to bring it in. I'm going to bring it into the edge of the board. I'm doing the same stuff again. Where's my pen? Oh jeez, I dropped my pen. Hold on a minute. I'll find it. Pen. Oh, here it is, rolled under my ham radio. What a good spot for that. Okay, so again, we're gonna put this down. We're gonna mark the far side of the pad. Try to mark the far side of the pad anyway. So we're gonna pin this down. We're gonna mark the far side of the pad and the far side of the pad. I mean, it ain't exact, but it's close. Then we're gonna snip it off. Come on. And then we're going to bend the leads. Again, we're going to bend the leads in line with the part. That's better. Making the feet on this one just a little bit bigger. I don't know if it's going to help at all, but okay. Try to a little bit more 90 degree-ish. Alright, I'm going to check it again. Always good to check twice. And of course I got it too big. Let me bring this one back a little bit. Yeah, that's pretty close. Okay, same thing. We're going to, I'm just moving these leads because one was up from the other, and so if you put one on the other one won't lay flat. Okay. So now we'll do the same thing we did before, and we'll put a little solder on there. Okay, so what did we forget to do? We forgot to tin them first. I can tell that because I'm having a hard time getting them to stick, but that's okay. Okay, so that one, that one. There. I just didn't like the way that one looked. Careful, make sure you don't. Again, you don't want to touch that inside leg to this guy, right? Doesn't show that on the diagram. So now we've got this one actually went in a little better. It's a little more even. But again, when you go to put the transistor in, you can just carefully bend this up. And just carefully bend this up and slide the transistor legs right underneath it. Okay? And there's plenty of room, there's plenty of room in there for you to solder those transistor legs. I am not going to mount the transistors. That is the last piece of this project, is to mount the transistors. I'm not going to do it until I know what heatsink I'm going to use. Okay? So, I hope that this was helpful to anybody that's ever wanted to put one of these together and was frustrated by the fact that no one has a build video. If when I go to complete this and test it, I find out there's something wrong, I will make a chapter 2 video explaining what I did wrong, if I did anything wrong. But I certainly hope this will help. And that's basically the whole thing except for the transistors. And obviously I have not, this is where power comes in. And boy, I'll tell you what, using plated on top holes for that really scares me. Because this thing draws a couple of amps, so good luck soldering those in and making it real good. But in any event, I hope this helped, and your comments are welcome. I'll probably ignore them, but thanks a lot for hanging with me, and I hope this helped you at least figure out what parts go where, what the parts orientations are, and some my bumbling attempt to try to make it a little bit easier. Thanks so much for watching, and have yourself a great afternoon.